Hello everyone, welcome to today's webinar. Today we will go over the second section in Unit 2 from the Algebra 1 course. For some of you, Algebra 1 is a required course that you need to finish and complete and pass in order to receive your diploma. For some of you, Algebra is an elective that you chose to study. As I said, today we will continue on Unit 2 on equations and inequalities. Today we will look at how to solve a system of equations. This is myself. My name is Miriam. I'm your math instructor at Penn Foster. I'm certified to teach high school mathematics in the state of Pennsylvania. Also, I have my master's degree in education. Today in this webinar, we will cover the most challenging topics in that section in Unit 2 that talks about solving systems of equations. During the webinar also, we're going to have some self-check questions that are not graded. Those ones will be questions that will be provided to you to answer depending on the discussion that we had done so far in the webinar. Also, your questions are welcome. Please keep them relevant to what we discussed today on the presentation. You can type in your questions using the questions box. Also, all registrants, whether you attend today or could not attend with us today, will receive a recording for the webinar to watch as many times as you wish. In today's webinar, we will look at different methods on solving a system of equations. We will look at the multiplication and elimination method. We will look at the elimination method. We are looking at the substitution method and when do we need to use each one. Also, we were able to distinguish between different types of system of equation, consistent, dependent, and inconsistent systems. We will look at one word problem that asks you to construct a system of equations, solve the system to come up with the answer for the word problem. Let's start with a simple question. Now, if you remember from the previous webinar, part 1 from Unit 2, we were looking at one equation only, and that equation had only one variable, either x or y. Now, having one equation and one variable that is unknown, it was possible for us to look at that one equation and add or subtract or divide, do our operations in order to find the value of that one variable. Now, it comes a problem when you have a one variable, one equation like that, 2x plus 5y equals to 10, but you have two unknowns. You have an x and a y. In this situation, you are looking for another equation that defines x and y. And that system basically works with the two variable. So I would like to, for us to understand why do we call it a system. So when we are solving the system, we have in mind why we do what we do. So in the first equation, it basically says 2 times the value of x plus 5 times the value of y should give you a 10. Also, those same values of x and y, if x minus 2 times the same value of y should give you -6. So that's why we call this system or these two equations a system of equations. How do we solve for x and y? For sure, it's not going to be the same steps as the single one equation and one variable. It will be similar. Some steps that we will have to do we had done before in the one single equation with one variable. But there are some methods that we need to learn how to use in order to find x and y. The first method I would like to go over is multiplication and elimination. Now, as the name of that method implies, we will multiply and will eliminate one of the variables, and then we'll be able to find the value of one variable. Using that value of one variable, we'll be able to find the value of the second variable. Let's translate what I have said in terms of math and how would we do that. So let's look at the two equations. Our goal, and those notes on the right-hand side of the slides will have a summary of the steps or the overall concepts of what we're looking for, what is our goal in each question. So our goal always in solving a system of equations is to make a variable like in the x and the x having the same coefficient. A coefficient is the number that appears before the variable. So 2 is the coefficient of x in the first equation. Our goal is to make x once with a 2 and once with a negative 2, the same coefficient with an opposite sign. Our goal is to use multiplication to alter either the first or the second equation again for one of the variables to have the same coefficient but with opposite signs. Now I see the easiest way to do that is to look at the x. I have 2x and 1x. I can easily multiply the second equation, x minus 2y equals to negative 6 times a negative or a positive 2. So that way, if I am able to multiply the equation times 2, then that would be something that we are able to work with. So let me then put the negative here. I think the question has a negative here. So we have a minus 2 or a negative 2 as a coefficient for the first x. The second x is a positive. So all we have to do is multiply the second equation times 2 to make the coefficient of the second x in the second equation a positive 2, since the first one is a negative 2. So multiply the whole equation times 2. The whole equation times 2. When we do that, we will realize that the first equation will stay as is. Negative 2x plus 5y equals to 10. It's the same. Now the second one is the one I'm trying to alter. 2 times x is 2x. Minus 2 times 2 is 4, but we have a minus here because it was a negative 2 times 2 is a negative 4y, and equals to 2 times negative 6 will give you a negative 12. Now look at the x's. We have arrived at the goal. The goal is to have the x once with a 2 and once with a negative 2. When we have that, we're able to add both equations and eventually eliminate the x. Let's do that. So the first step I did here is one, we multiplied. So that's the first section of the method. The second section is eliminate, and elimination comes when you add the two equations. So add them. So you have a negative 2x plus 2x, that's a 0. The x's have been eliminated from the equations. We only have now the y's. 5 plus negative 4 is a 1y, which is we write as a y, equals to 10 plus negative 12 will give you a negative 2. Look what we have. We have a value of y. This is one of our answers. Y equals to negative 2. I'm going to square the answer so it's obvious that this is one of the answers we're looking for. The second answer we're looking for is the value of x. How would I find the value of x? Well, these two equations defines the relationship between y and x and y and x. So I need to go back to one of the original equations given in the question, plug in the value of y in one of them, and I'll be able to solve for x. Let's do that. So the next step, I'm trying to solve for x. So I'm gonna pick the simplest equation. So this equation has too many coefficients. I'm gonna go with this one since the numbers are lower. So it's gonna be easier for me to work with the numbers when I plug in the negative 2 in place of the y. So x minus 2y, which is 2 times negative 2, because y is negative 2, equals to, or should equals to, negative 6. Now, this is a simple equation. This is the webinar 1. Part 1 of this unit taught us how to solve an equation in one variable. Let's simplify. X negative 2 times negative 2 is a positive 4. Pay attention to signs. Signs will make a big difference in your answer. When you multiply negative times a negative, make sure you have a positive. 4 equals to negative 6. Now, what we have done in this case is that we say, well, x is added to 4, do the opposite, then subtract 4 from both sides to keep the equation balanced. Now, x will be the same. 4 and negative 4 just will go. And negative 6 plus negative 4 will give you a negative 10. Now, x equals to negative 10 is the second answer I'm looking for. So our answers are x equals to negative 10 and y equals to negative 2. Now, what if you're not sure? You have done the work, you think it's correct, but you are not 100% sure that these are the right values of x. If you're not sure, go back to the original equations, plug in x and y in one of those equations. If it gives you the value on the right-hand side of the equation, then your values are correct. I'm going to do one check here in this question just to show you how would you check for your answer if it's good or no. So let's do the top equation since we did not use that before. So I'm saying that negative 2 times x, which is negative 10, plug in the value, plus 5, y is negative 2 times negative 2 should equal to 10. Does it equal to 10? So I'm going to put a question mark and see. Negative 2 times a negative 10 is 20. Positive 20. And then 5 times negative 2 is a negative or minus 10. Does it equals to 10? Well, 20 minus 10 is 10. So the left-hand side equals to the right-hand side. Our values are correct. So this is how we check if our work is correct or not correct. Any questions so far? Anything that was not clear? You can type in your questions, by the way, in the questions box. If you have one on this question, I'll be able to see your question and who asked the question. Let's move on to another example. The same method we're going to use. So as I always say in my webinars, algebra is like a language. If you practice the language, you acquire the skill of speaking that language. But if you just watch people speaking, for example, Spanish, you will never speak Spanish unless you use the grammar and the vocabulary and everything. The same thing with algebra. The more you do, the more you practice, the more you're going to get the hang of things. Once you look at the two equations, you will realize what you should do in these two equations to arrive to the first goal that we have. We need to have a variable with the same coefficient top and bottom, one with a negative sign and one with the positive sign. What should I do? What should I multiply? And which equation should we multiply? Well, I see that 10 and 5 gives me an idea. Well, 10 is a multiple of 5. So I have t here has a negative sign and t has a negative sign. So probably what I'm going to do is multiply the second equation times a negative 2. So I'm going to multiply the second equation times negative 2. Because negative 2 times a negative 5 will give you a positive 10. So 10 and 10, one is negative, one is positive. This is what I'm trying to arrive at. Okay, so the first equation will stay as is. And I think this negative sign should go away then. So our question is 2s minus 10t equals to 16, and the other one, 3s minus 5t equals to negative 22. Now rewrite the first equation as is. We did not do any changes here. 2s minus 10t equals to 16. The next one, we need to multiply every single term in the equation times a negative 2. Negative 2 times 3 will give you negative 6s. Negative 2 times a negative 5 is a positive 10t equals to negative 2 times a negative 22 is a positive 44. Now I see that the t is once with a negative 10 and once with a positive 10. I'm ready to eliminate the t. So add both equations. 2 plus negative 6 will give you a negative 4s. These two t's will just cancel out to be a 0, equals to 16 plus 44 will give you 60. Now, negative 4s equals to 60. That's not our final answer for s. We need to isolate the s by itself, then divide over negative 4 and divide over negative 4. S equals to negative 15. A positive over a negative is a negative. So this is our first answer, S equals to negative 15. Now let's try to find the value of t. I can use any one of the original equations. So let's do the top one. It has, yes, it has bigger value, but it's not going to matter because every equation here is true. It's a true statement. So let's try and use the first one. So I'm going to say 2s, when s is negative 15, then I'm going to put the negative 15 in place of the s. Minus 10t should equal to 16. Simplify. 2 times negative 15 is negative 30. Minus 10t equals to 16. I'm going to finish up the work over there. So I have negative 30 minus 10t equals to 16. I'm going to rewrite that on the top so we are able to decide on what's the next step to solve that one equation in one variable. That would be the first part of this unit. Well, I need to isolate the 10t, so add 30 and add 30. Since 30 has a negative sign, so that's a subtraction, equivalent to subtracting 30. So add 30 to both sides. This is 0. Negative 10t equals to 16 plus 30. 16 plus 30 will give you 46. Now, I'm not done with the t. Divide over negative 10 and divide over negative 10. So negative over a negative, that's a positive 1. So it's a t equals to 46 over negative 10 will give you a negative 4.6. It's a decimal answer, but it is the right answer. Whenever you get a fraction or a decimal as your part of your answer, do not panic. It's just the right answer. Now, this is the second value we're looking for, t equals to negative 4.6. How do I know that these values are correct? Well, plug them in one of the top equations. If they give you the values on the right-hand side, then your values are correct. Other questions? Any questions on how to solve the system of equations using multiplication and elimination? Anything that was not clear or did not match what you've read in your units? Okay, let's move on to a self-check question. As I said at the beginning, those questions are for you to assess yourself, to assess your understanding. Those are not graded, and I don't even have time to look on who did the question correctly and who did not. We are here to learn, not to judge. So here is a question very similar to what we have been talking about since the beginning of the webinar. Now, I'm going to leave that screen for about 30 seconds. You can copy the question down and work on the question, and then I will switch my screen to give you again the same question, but this time with the ability to choose the answer and submit your answers. So you can start working on that question, and I hope that everyone participates. Really, it's something for you to see if you have grasp the concept or you still have questions. And it's good that you have a live person that you can ask question and they can answer at the same time. I'm going to remain quiet for a few seconds so you're able to focus on those questions and do them. Okay, I'm going to change now my screen to give you the same question, and now with an option to select your answers. Okay, if you did not have the chance to submit your answers, you can pause the video when you receive the recording in the follow-up email and work on the questions. I'm going to share my final answer. The correct values for P and Q are answer D. P equals to negative 2.5 and Q equals to 2. As I said before, if you got that question incorrect, it does not mean that you will never get how to solve the system equations. It's just a hint for you to go back to the lesson, read, practice, call the school, email the school, use the resources available to advance in this topic. Now let's look at another kind of question that we may see in the exam or throughout our units. And this method is just the elimination method without the multiplication part. Now, how do I judge then when do I use multiplication and elimination or only elimination? We can look at the equation and decide the equations and decide ourselves. So negative 5u minus 5v equals to 15, and the other equation is negative 10u plus 5v equals to 60. Look at the v's. One with a negative 5 and one with a positive 5. It's already done for me that the coefficients are the same with opposite signs. So all I have to do is eliminate. When I eliminate the v, I add the two equations. And that's why we just call it the elimination method without having to multiply anything. So negative 5 plus negative 10 will give you a negative 15u, and negative 5v plus 5v just will cancel out to be a 0, equals to 15 plus 60 will give you 75. I'm close to get the value of u. Divide over negative 15 and divide over negative 15. Negative over a negative, it's a positive 1. So u equals to negative 5. So positive over a negative is a negative. So u is negative 5. All I have to do is plug in the value of u in one of the original equations to find out the value of v. So let's do that together. Let's pick the first equation. Negative 5u, which is times negative 5, because u is negative 5, minus 5v equals to 15. Simplify. Negative 5 times a negative 5 is a positive 25, minus 5v equals to 15. I have my variable added to negative 5, do the reverse. So subtract negative 25, or subtract 25 and 25 from both sides. So that will be a 0. I'm going to have a negative 5v alone on one side, and then 15 minus 25 will give you a negative 10. I'm not done with the v. I have a negative 5 times v, then reverse. Divide over negative 5 and divide over negative 5. So far, we have 1v, which is v, equals to negative over negative is a positive, and it's going to be a positive 2 because 10 over 5 is 2. I have both answers, u equals to negative 5 and v equals to 2. Again, if you want to check your answer, plug those values in any of the original equations, should give you the value on the right-hand side of each equation. Any questions so far? Okay, let's move on to another self-check question. Look at the equations and decide, is it multiplication and elimination, or it's ready for us just to eliminate? I'm going to keep that for 30 seconds and then change my screen. Okay, I'm going to give you the question with the ability to check or choose your answers, and here you go. Which values are correct for C and D? Okay, so the final answer, just for your reference, if you get the recording, please try those questions one more time. The answer is B, C equals to 2 and D equals to 1. Okay, let's look at a different method, the substitution method. How can we use substitution to solve a system of equation like the one we have here on the screen? As the name of the method implies, we're gonna substitute one expression and put it in place of one variable in any of the equations that we see here, depending on what's given. Now, usually the question will say, sometimes because it's a multiple choice exam, it says use substitution method to solve the system of equations. But because it is a multiple choice exam, you can choose whatever method you want to do, elimination or substitution. So whatever you feel comfortable with. So let's say that you have to use this method to solve the system of equations. What they mean by that is we need to look at the simplest equation among the two that we have. We have 12x plus 2y equals to 20, and x plus y equals to 5. Apparently here, as you see, the coefficients for x and y in the second equations are only 1. That makes it the simpler of the two equations that we have. So we can rewrite the second equation so we describe x in terms of y. Okay, and this is what I mean by that. So this equation, we can look at it as x equals to 5 minus y. How did I come up with this? I actually solved for x. So I subtracted y and minus y from the other side. So I have x by itself, that's gone, equals to 5 minus y. What I actually did, I just rewritten the second equation. So x is defined in terms of y. Okay, why is this step is so beneficial for us in this method? Because eventually what I'm going to do is I'm going to remove this x, and put this expression in place of this x, and then solve the equation. And at that time, this equation will have a one variable. So we'll go back to the section 1 of this unit where we have to solve an equation with one variable. Let's do that just to make it clearer on what to do in this method. So I'm going to erase this part and this one. And let's use the expression 5 minus y in place of the x in the first equation. So we are basically saying 12x, so 12 times 5 minus y, because the whole expression 5 minus y is equivalent to the x. So that's why we have to multiply 12 times everything here. And then plus 2y equals to 20. Simplify. Remember when we talked about in Unit 1, when we spoke about multiplying a number times a binomial, we said that we just multiply or distribute that one number over each term in the binomial. We're going to do the same thing, the same rules. 12 times 5 will give you 60. 12 times negative y will give you minus 12y. The rest of the equation will just stay the same, plus 2y equals 20. Now I see like terms. Negative 12y and 2y are like terms. From Unit 1, we learned that if we have to add terms and they have the same exact variable, in this case y, we can combine them. So 60, and then negative 12 plus 2 is negative 10, so it's minus 10 y equals to 20. Now it became an equation, one equation in one variable y. Do the same thing as the first section of this unit. I have the 60 added, then subtract 60 and subtract 60. 60 minus 60, that's gone. You have negative 10y in one side, and this side 20 minus 60 will give you negative 40. Now I'm not done yet. Divide over negative 10 and divide over negative 10, then y equals to 4. Negative over a negative is a positive. So this is the first value that we're looking for, y equals to 4. Before I leave that step, all I have done is took the value of x, because this equation, when I rewritten the equation, it tells me actually x is equivalent to 5 minus the second variable. So I took this, put it in place of this variable x, and I just distributed, I simplified, solved the equation in terms of y, and that's it. Now I need to figure out what is x in this case. Well, I know y. I can pick the simpler equation here and say, well, since y is 4, that means, according to the equation, that x plus y, which is plus 4, should equal to 5. Another simple equation, one equation in one variable, subtract 4, subtract 4. 4's are gone. X equals to 5 minus 4 will give you a 1. X is 1 and y is 4. That's it. Questions? Anything that was not clear? Let's do another example with the same method. You are having another system of equations. Solve the system of equation using the substitution method. What should I do? Well, if I look at the second equation, they already rewritten the second equation describing b in terms of a. b equals to 5 minus a. All I have to do is take that expression, which actually the b, and put it in place of this b, and at that time we're going to have one equation in one variable. Let's do it. So 7a plus 3 times b, meaning 3 times 5 minus a, and that should equal to negative 1. 7a will stay the same, plus 3 times 5 is 15. And 3 times negative a is negative or minus 3a, equals to negative 1. I have negative 3a and 7a, like terms, then combine. 7a minus 3a is 4a, plus 15 should equal to negative 1. Now I have this variable added to 15, subtract 15, and simplify. I have a 4a, that's gone, equals to negative 16. Be careful, it's negative plus a negative will give you a negative answer, but you have to add 1 and 15 is 16. So 4a equals to negative 16, divide over 4, and a should equal to a negative 4. I have the value of a. I can simply pick any equation from here and plug in the a as negative 4, and that will give me the value of b. I'm going to choose the simplest of the two equations. You can go with the harder. You can, but just be careful, do it correctly. So I'm going to say, well, since a is negative 4, and they are saying that b equals to 5 minus a, so 5 minus negative 4, then b equals to 5 plus 4, or b equals to 9. And this is the final answer. b is 9 and a is negative 4. Any question? As I said, it may seem overwhelming to deal with all of those rules at once, but practice is the key. When you practice, check your answers, read the lesson, check your answers within the lesson, watch that webinar again, do the self-checks within the webinar. It will make a difference. Okay, another one question with self-checks, and use the substitution method to solve the following system of equations. So I'm going to leave that for a while and then switch to the other screen. Now, just to give you a hint here, the first equation is already rewritten. They give you y in terms of x, so this is the expression that you will use in place of the y. Okay, I'm going to give you the question and the answers. Okay, let me share my final answer. As I said, if you did not have time today to finish this question with us today, you can get the recording, pause the video, do the question, and check your answer. And the answer is C. Okay, let's move on to the types of system of equations that we know of. So far, the system of equations that we have solved, and as you saw, that each variable had only one solution, and those systems that we have been dealing with, we call them consistent systems. They are the normal type of systems that you will often see and you'll be asked to solve. There are special types of system of equations that we call them dependent, or another type, it's inconsistent systems. How to tell the difference? So I brought two kinds of system of equations, and I'm going to show you when we solve each system, we will realize which type is each system. So let's start with the one on the left. So typically I have two equations. My goal is to make one variable with the same coefficient, the same variable in the second equation with the same coefficient but with opposite sign. So I'm going to multiply the first equation times -2 because I have a +2 here. So -2. So the first equation will be rewritten as -2x minus 6y equals to -46. Bring the second equation as is. We did not change anything in this equation. And the next step is to eliminate. When you eliminate, you add. And look what happens here. -2x plus 2x is a 0. -6y plus 6y is a 0. So that is a 0. Equals to -46 plus 46 is a 0. When you are solving a system of equations and your solution just bring you that line 0 equals to 0, it means that those two equations are really one equation. They are the same equations. They are not different equations. And in this case, we call this system as a dependent system because one equation actually depends on the other. So it is dependent system. So it will be this type. Now, what about an inconsistent system? What happens? What happens in our solution that makes us say this is an inconsistent system? Let's solve as we would do normally. So we have 3x plus 9y equals to 25. The other one is x plus 3y equals to 3. Well, I can multiply the second equation times a -3, and that's how I'm going to get my x to have a -3 coefficient. The one already have 3 on the top, so that would work. So copy down the first equation as is, equals to 25. We're going to alter the second equation. That would be a -3x minus 9y equals to -9. Now let's eliminate. So add both equations. Of course, 3x plus -3x is gone. 9y plus -9y is a 0. So this side actually is a 0, equals to 25 minus 9 will give you 16. Now, is this statement true? Is 0 equals to 16? That is not true. This statement is not true. So if you solve the system of equations as you normally do, and you end up having an incorrect statement, that means that this system is not solvable. There's no solution to x or y. So we call this system, in that case, inconsistent system. Inconsistent system, meaning that there is no solution for this system. There is no way that when you multiply 3x plus 9y gives you 25, and those same values, you add the x plus 3 times the value of y should give you 3. It will never happen. So this is the example of an inconsistent system. Questions? Okay, let's go to a self-check. And will, of course, ask you to indicate if this system is a dependent, consistent, inconsistent, and or independent. Which one that you think this system is. The only way you're going to figure it out is to start to solve the system as we normally do, and then figure out what you have while you are solving the system. Okay, I'm going to put the question up for you to try. So which kind of system that we're dealing with here? Dependent, consistent, independent, or inconsistent? Okay, let me share my answer. Actually, the system that we are dealing with is a dependent system. It is a dependent system. If you start working on the solution, you will find out that 0 equals to 0 is part of our solution. That will tell you that this system is a dependent system. Those two equations actually are the same. They are equivalent. Well, they don't look the same, but if you multiply 2 to this equation, see here, 2 times 2 is a 4, w minus 2x equals to 10. This is the same exact equation. And if you want to solve, you then have to multiply this equation times a -2. So that would be a -4 plus 2x, -10. Add them, it will just cancel out everything. So 0 will be on the left and the right-hand side of the equation. That's why it's a dependent system. Okay. One last example that I would like to go over. I usually do not go over word problems. I think that students have to, use the concept that we do in our webinar and utilize them in word problems and use their understanding. But with the systems of equations, it's a little bit overwhelming to, work with words, extract information, construct equations, and solve them at the same time. So I brought this question. I just made it up. So if the numbers doesn't look realistic, you know why. Let's read the question together. So Tina bought 5 t-shirts and 8 pairs of leggings and paid $140 in total. If one t-shirt costs $2 more than one pair of leggings, then how much each t-shirt and each pair of leggings costs? So we realize that we are not able to just construct one equation. We have to construct two equations. Those two equations will make up the system of equations that we need to solve to find the two variables. The variables in this case would be the cost of each t-shirt and the cost of each pair of leggings. How do we start? One, I like to assign variables to what's going on here in the question. We have t-shirts and leggings. I always go with variables that make sense. So as we're solving, we also make sense of what we do. So I'm gonna call the cost of the t-shirt T, it's a t-shirt, and for leggings, I'm gonna call it L. So T is the cost of one t-shirt, L is the cost of one legging. Now the question said that she bought 5 t-shirts, so 5 times the cost of one t-shirt. Also she bought 8 pairs of leggings, so 8 times the cost of one legging, and then she ended up paying $140. This is one equation. Also, in the question, they gave us another piece of information that we can use to construct the second equation. They said that one t-shirt costs $2 more than one pair of legging. So it means that T, the cost of one t-shirt, minus the cost of one legging, the difference of these is 2. I have 2 equations, and those 2 equations use the same 2 variables and creates my system. What should I do? I'm going to apply the same methods. I'm going to pick the method that I feel comfortable dealing with. I'm going to solve as we did since the beginning of the webinar, and it will give us T and L as values, and those values will be in dollar. Okay, for myself, I like to use the substitution method. You can use another method of your choice, but I see that the numbers are big, so you have to multiply. Your numbers will be ambiguous, so I personally will go with the substitution method. So let's do that together. From the second equation, I conclude that T equals to L plus 2. What I did actually is I added L and added L. I just want to show you how did I find out this part, and T that will cancel out equals to 2 plus L, which is the same thing I have here. So I described T in terms of L. I described the cost of one t-shirt in terms of the cost of one legging. Okay, and it makes sense. The cost of one legging plus $2, that will give you the cost of one t-shirt. Okay, let's then proceed to the actual solution then. So I'm going to use L plus 2 in place of the T in the first equation. So 5 times T, so times L plus 2 plus 8L equals 240. Okay, distribute the 5 over the L and the 2. 5 times L is 5L. 5 times 2 is plus 10, because positive times positive. And then I still have plus 8L equals 240. Now I have two like terms, L and L. 5 and 8 is 13. So 13L plus 10 equals 240. I'm not done yet. I need to get rid of the 10. So subtract 10 and subtract 10. 13L, that's gone, equals 230. Divide over 13 to get rid of the 13, and divide over 13, and that will tell us that L equals to $10. $10. So that is the cost of one pair of legging. Well, we know from this equation or this equation, the same if you want to use, that one t-shirt costs $2 more than L. Let's do it algebraically. So I'm going to use the original equation, T minus L, so minus 10 should equal to 2. So add 10 and add 10. So T equals to, that's gone, equals to $12. And it makes sense. It goes with everything given in the question. So the t-shirt costs $12 and one pair of leggings costs $10. So $12 and $10 are our answer. Any questions? Anything that didn't make sense? Okay, you can type your questions in the questions box if you have any. Okay, then that was it for my math part of the webinar. We so far in this webinar went over the elimination method, multiplication and elimination methods, substitution methods, and all these three methods are used to solve system of equations. Which one to use, it's up to you. And sometimes you are kind of forced to use one method over the other if, for example, elimination will make you go through a headache with big numbers and too much work to do. So maybe substitution would be the solution here. We also learned different types of system of equations, consistent, the ones that we solve and find solutions for, the dependent, which is the ones that we have a 0 equals to 0, which is really the same equation given twice. And the last one is the inconsistent system, where there's no solution for the given system. We also looked at one word problem and learned how to construct our system of equation and solve it. Now for the exam, for sure for the exam, for this unit's exam, if you do not have a strong background in algebra, then I would expect you to read the unit carefully. Do the examples given in the unit. Watch the recorded webinar once or twice as much as you need. Do the practice questions yourself. You need to keep a notebook. So math is different than other subjects that you sometimes, and that's true with me, if I read something, I just remember it for a few weeks ahead. But with math, you need to pick up your pen, prepare a notebook, make it organized, do the questions yourself. You have to write, you have to learn, where do you fall? Is it the signs that confuse you? Is it adding the signed numbers? Is it the ordering of the steps, what comes first in the solution? You need to discover what makes you confused. So keep a notebook, do the self-checks or the practice questions or discover more, whatever they're called in your unit, do them, check your answers with the answers provided. So we provide the answers for those questions so you're able to assess yourself without having to wait for us to be in office to ask us what is wrong with my answer. Also, khanacademy.org is a good site. I have looked at this site this morning. I made sure that they have a good resource. It's an outside resource. It's not a Penn Foster resource, but some of you requested that you want additional resources for topics in Algebra 1. So if you go to khanacademy.org, and then you will find an icon on the top left corner of the page. It says subjects. You click on subjects. A drop-down menu will give you every single subject that they cover. You're going to click on Algebra 1. And then under Algebra 1, you have multiple topics. The one that corresponds to our lesson today is systems of linear equations. Linear equations mean that the variables are not raised to a power. So it's an x or y, not x squared, for example. So systems of linear equation is the series that they have. They have quizzes, they have videos, they have practice questions and everything like that if you want to do more work. If you only do the things that we provide with the Penn Foster portal, I would imagine that would be sufficient for you to grade good in the exam and build up on your algebra skills. Also, you can call the school 9 to 6 Eastern Time on weekdays. You can schedule an appointment with an instructor or a teacher assistant. This is the link. Unfortunately, you cannot click on the link when you get the recording of the webinar, but it's not so hard to, type in those letters on the web address box, and that will get you to the page where you can set an appointment with an instructor or a teacher assistant with any course. Actually, you're going to just click and choose the math courses. We'll give you options of the courses. Choose the time and the date that you're going to be free, and we will give you a call back on those times that you specified. Another thing that I would like to go over, because sometimes it's confusing for students, on how to email your instructor. Let's say you cannot speak over the phone, you have kids around, or you don't have your own room, you are sharing that room with a sibling, you cannot speak over the phone. So you're able to email. And the left-hand side of the screen is a type of accounts that some of you have. So those are the steps that you can follow: 1, 2, 3, 4, 5. You can pause the video when you get the recording and follow that, and that will get you to this form, and this is where actually you type in your question and send your email to the school. Or some of you have this kind of account. Again, you're going to follow those steps, and that will make you send an email to your instructor. And thank you. And that's it for me. If you have questions generally on the program or the course, or maybe in that lesson, you're welcome to type in your questions and I'll do my best to answer them. You are welcome, Jenny. I hope that this webinar have given you at least a peace of mind that systems of equations is not that horrible topic in the Unit 2 that you will never understand. My goal always is to simplify math to students, and I hope that I did reach my goal, at least to give you a kickstart on, study that unit. It's not that difficult. It's not the monster that you will never understand. So thank you for your attention. If you don't have any questions for me, I will end the webinar and I will wish you then good luck in the exam. Okay, good luck.